British Museum, catalogue number K8538, recovered from the ruins of Nineveh by Henry Layard in 1849. Curators logged it as a routine astronomical planisphere from the 7th century BCE. Background noise from the ancient world. But the tablet is a copy. A faithful Babylonian reproduction of a much older Sumerian original, copied and recopied for over 2,000 years because something on it was considered too important to lose. In 2008, two engineers at Bristol University fed its coordinates into modern trajectory software. The numbers were not symbolic. They described a real flight path, a kilometre-wide object crossing the night sky on a single specific date. Today we are going to do three things: decode what the Sumerian astronomer actually saw, examine the impact site modern science says it hit, and uncover the catastrophe that followed. Subscribe. Your assumptions will not survive intact. K8538 is not a curiosity. It is a Neo-Assyrian copy of a Sumerian original recovered from the Royal Library at Nineveh, and it was treated by Babylonian astronomers as a document of maximum priority. Preserved through 1,500 years of careful copying, refreshed when the clay began to crack, guarded when other tablets were discarded. Whatever it recorded, the scribes who inherited it believed it had to survive. The men who produced the original were professionals. The Sumerians called them Tupshar, Enuma, Anu, and Lil, the scribes of when the heavens and earth were named. Their job was to watch the sky and write down what it did. The observation towers at Ur stood over 20 meters tall, staffed in shifts to ensure continuous coverage. They measured angles with their own bodies. A finger held at arm's length equaled roughly 1 degree of arc. A fist, 10 degrees. Crude in description, precise in practice. Their eclipse predictions, when checked against modern computation, hold to within minutes. The Venus tablet of a Misaduka documents planetary cycles across decades with a margin of error contemporary astronomers consider extraordinary for naked eye work. These were not mythmakers. They were observational scientists, generations deep into a discipline that depended on getting the sky right. K8538 is unusual within their corpus. Half the tablet is routine. Planet positions, cloud cover, the kind of entry the towers produced every night for centuries. The other half is something the scribes had never recorded before, a single object large enough that its shape could be drawn while it was still in space. In 2008, two researchers at Bristol University published the first comprehensive technical translation of K8538. Alan Bond, managing director of Reaction Engines, Mark Hempsell, senior lecturer in astronautics. They were not Assyriologists. They were aerospace engineers. That mattered. What previous translators had read as constellations or symbolic ornament, Bond and Hempsell recognized as engineering data. Angular bearings, elevation measurements, time-stamped observations of an object in motion across a known starfield. They modeled the trajectory using the same software class used for satellite reconstruction, the kind of program that takes a sequence of positional readings and tells you whether they describe a real object on a real path or random noise. To an accuracy of better than 1 degree, the Sumerian observations described a real object. The date the software returned was specific to a single dawn. The early hours of June 29th, 3123 BCE in the Julian calendar. The astronomer at his post had logged the planets, noted the cloud cover, and then watched something cross the pre-dawn sky from the southeast. Close enough to draw, large enough to record its rotation, moving fast enough to see it travel across the starfield in real time. The classification Bond and Hempsell assigned it was an A10 class asteroid over 1 kilometer in diameter. The trajectory pointed northwest across what is now the Mediterranean toward Central Europe. The math said it did not burn up. The math said the object continued past the horizon and came down somewhere on the far side of the sky. In the Ötztal Alps of Austria, near the village of Köfels, geologists in the 19th century identified an unexplained landslide, 5 kilometers across, 500 meters thick. Mid-20th century researchers argued it had to be the result of a meteor impact. The crushing pressures, the fused rock, the explosive signatures all pointed that way. Then the consensus shifted. Modern impact science said an event that violent should leave a crater, and Köfels had no crater. The site was reclassified as a freak landslide and quietly set aside. The puzzling features were never satisfactorily explained. The file was simply closed. Bond and Hempsel's trajectory pointed straight at it. Their proposal explained the missing crater. The asteroid, they argued, came in at a shallow angle of around 6 degrees. A grazing entry. It clipped a mountain ridge before reaching the valley floor and fragmented in midair. The main mass exploded above the ground, gouging the landscape without producing the deep circular pit a vertical impact would carve. Hempsel took the model further. The back plume, the mushroom cloud rising from the explosion, would have curved southeast over the Mediterranean and re-entered the atmosphere over the Levant, Sinai, and northern Egypt. The thermal pulse would have been brief but lethal. Anything flammable beneath that returning plume, hair, cloth, dry vegetation would ignite. Hempsel's quiet conclusion was that more people likely died under the plume than at the impact site itself. That secondary kill zone covered the cradle of every Bronze Age civilization in the eastern Mediterranean. Not every researcher agrees the object struck the ALPS. In 2001, geologist Sharad Master at the University of the Witwatersrand identified something on satellite imagery of the southern Iraqi marshlands. A circular structure, 3.4 kilometers across, polygonal-rimmed, geometrically distinct from every other lake in the region. He named it al Binni. Sedimentary context placed its formation within the last 5,000 years. Master's proposal was direct. Al Binni was an impact site. The energy release would have been equivalent to hundreds of Hiroshima-scale weapons. A wet impact in the shallow marshlands would have generated tsunamis that lashed every port city in Mesopotamia within hundreds of kilometers, Uruk, Shurupak. The 2.5-meter flood layer found beneath the ruins of Ur, long puzzled over by archaeologists, would not be a river flood at all. It would be a tsunami deposit. The dating master argued for points to a slightly later catastrophe, closer to 2200 BCE, and connects the impact to the 4.2 kilo-year event. The abrupt climate downturn that coincided with the collapse of the Akkadian Empire, the abandonment of cities across northern Mesopotamia, the famine recorded in the surviving city laments. A separate research program by Joachim Seifert and Frank Lemke argues K8538 records that later impact, not the Köfels event. They fixed the strike at 10:56 in the morning, September 22, 2193 BCE. 2 reconstructions, 2 craters, 2 different centuries. But both rest on the same tablet, and both end the same way. Something kilometer scale came down out of the sky. Whichever model is correct, the period between 3100 and 2100 BCE in the ancient Near East shows distinct catastrophic signatures that mainstream scholarship still struggles to fully explain. At Tel Leilan in northern Syria, archaeologist Harvey Weiss documented a thick volcanic-style ash layer dated to roughly 2350 BCE. It sits directly above the floors of abandoned buildings. The cities of the Habur Plains were vacated within a single generation. The Akkadian Empire, the world's first multi-ethnic state, fragmented. The Sumerian Curse of Akkad, written shortly after, describes a fire from the sky and a sudden silence in the temples. The geological signal extends well beyond Mesopotamia. Sediment cores from the Gulf of Oman show a corresponding dust spike. Lake records in northwest Iran register the same sudden aridity. Glacial cores in Greenland register the climatic step down. Whatever happened, it was not local. Then there are the city laments. Texts mourning the destruction of Ur, the destruction of Sumer and Akkad, the desolation of Eridu, all written in the centuries after the catastrophe. fire from heaven, rivers running with ash. The sun darkened, the land made empty. Mainstream historians read these as poetic conventions. Bond, Hempsel, Master, Seifert, and Lemke read them as memory. The scribes did not stop watching the sky after this. They watched harder. The volume of surviving astronomical diaries multiplies in the centuries that follow. Something had changed in their understanding of what the heavens could do, and the change was permanent. K8538 is not a star map. It is a single night's observation, copied and recopied for 15 centuries because the scribes who held it understood what it documented. The moment a routine sky watch became the witness statement for a civilizational event. The astronomer at his post that morning logged the planets, noted the cloud cover, and then drew the shape of something that should not have been there. Mainstream Assyriology still classifies the tablet as a planisphere, a late Babylonian star chart, decorative, symbolic, unremarkable. Bond and Hempsel's translation has not been accepted by the field. The Köfels dating is contested. The al Binni crater remains uninvestigated on the ground because southern Iraq has been inaccessible to fieldwork for decades. The marshes drained in the 1990s, the site silted over, the geology unstudied. The 2019 inspection that Seifert and Lemke proposed never produced a published field report. The Bristol researchers were aerospace engineers, not Assyriologists. The Witwatersrand geologist worked from satellite imagery, not core samples. The Sumerian original is lost. Only its Babylonian copy survives. Every chain of evidence here has a missing link that the institutions with the authority to forge it have chosen not to forge. The tablet has been sitting in the British Museum for 176 years. The questions it raises have never been unanswered because nobody with the authority to answer them has been allowed to look. The Sumerian astronomer wrote his report. He left it in clay so it would last. It has lasted. It has not been read. Strip away the speculation, and what remains is something quieter. The Sumerians were among the most precise naked eye observers in human history. Their planetary records, their eclipse predictions, their decade-long observational logs, all verified against modern calculation. When one of those observers logged what crossed the sky before dawn on a single morning in deep antiquity, he was not writing myth. He was writing a field report. Modern astrophysics gives us a framework where that report is physically possible. Aten-class asteroids exist. Grazing impacts leave exactly the kind of ambiguous geological signature Köfels shows. Wet marsh impacts leave exactly the kind of polygonal lake al Binni is. Civilizations collapse around dates that match. The reason this matters is not the crater. It is the patience of the scribe who logged the sky and trusted that someone eventually would read it. The night sky keeps many secrets.